Our next unit is on simplifying and graphing inequalities. An inequality is a mathematical sentence that compares expressions. To write an inequality, look for the following phrases to determine where to place the inequality symbol. So if I said x is less than 5, I'd say x is less than 5. X could represent any number that holds that true. So 4 is less than 5. The inequality sign points towards the bigger number. I always remember it as the alligator eats the bigger number. Drew it as a little alligator here. There are 4 different types of inequality symbols. We have our less than sign, our greater than sign, a less than or equal to, or a greater than or equal to. Some key things that come up along the way, especially when we're hitting our pre-algebra level, are things like less than or equal to could be at most or no more than. I think of this as if I'm going shopping and I can spend at most $20. That means I can spend up to and including $20, but I cannot exceed that. For greater than or equal to, if I can spend no less than $20 on a present or an order of food, that means I spend $20 or more. So in our previous unit, we talked about equations. And inequalities and equations are very similar in how you solve them and work with them, but they are different. So for example, if I had x plus 5 equals 3, we learned in a previous unit that we would subtract 5 from each side and get x is equal to negative 2. So an equation has one solution. So this is one value that when you plug it back in, it works for you. An inequality is a little bit different. If we had x plus 5 is less than or equal to 3, we would solve it the same way, except this time, instead of getting one solution, we are going to get a range of solutions. So x is less than or equal to negative 2. So inequalities have a range of solutions that make them true. And this is known as a solution set. So if you're less than or equal to negative 2, that means you could be a negative 3, a negative 10, a negative 2.25, anything that's smaller than negative 2. So let's talk about our first example, graphing inequalities. So with inequalities, you have what's called an open dot and a closed dot. An open dot would be a less than or greater than sign, and a closed dot would be a less than or equal to or a greater than or equal to sign. A closed dot just means it includes the number that you're on. And an open dot means it doesn't include your number. So if we look at the first example, it says a is greater than 5. So if a is greater than 5, you have an open dot at 5. And if you're greater than it, that means you point to the numbers bigger. The direction of the arrow of that inequality sign actually tells you like what way to go. That's how I always remember it. So let's look at example 2. We have 2 and 1/2 is greater than b. Now, my personal preference for these are to rewrite it so my variable is on the left-hand side so I don't mess up what my inequality is actually saying. So this is really b is less than 2 and 1/2. So I go to 2 and 1/2, so that's 2.5. And it's less than it, so I'm pointing to the left. That's all you're going to do. There are special cases when graphing inequalities that needs to be taken into consideration. If you have a negative sign in front of your variable, like these two examples here, you have to divide by -1. Because technically, that v and that x, they're not alone yet. And whenever you divide by a negative, or multiply by a negative for your inequalities here, you have to flip the inequality sign. I know it's a weird rule, but whenever you see this, you have to remember to switch it. So for example 3, I divided each side by -1, and my inequality sign flips. So v is greater than 6. I have an open dot at 6, and I point to the right. Example 4, we're going to do the same thing. Divide by -1 to each side. So then x is less than -3. So your rules of negative divided by positive, that kind of thing, still come into play. So we can't remember our properties of integers there. So we have an open dot, and we're less than -3, so we point to the left. So our conclusion is, if there's a negative in front of our variable, so if you multiply or divide your variable, you must flip your inequality sign. Okay, our last example for today is writing an inequality for each graph based off the picture. These are probably my favorite because you don't have to draw the number line, it's already there for you. You just have to pay close attention to whether it is an open dot or a closed dot. So for our first example here, you see that we have a open dot at the number 5, and that our line is drawn to the left. So we can say x, or any variable really, is less than, so it's pointing to the left, 5. And that is all you need to do. Number 2, if we look at this, we can say y is greater than or equal to -2. Remember, closed dot means that it includes that -2. Our third example, we have a closed dot at 0, so we can say c is less than or equal to 0. And finally, we have an open dot here at -6, and it's pointing to the left, so it is less than -6. So you can pick any variable. Let's do an x again. There you go. So now what you're going to do is complete the Now You Try in your packet. When you are finished with this, come see myself, and we will move you on to Go Formative.